All right, guys, we're back. We're here today. Myself, obviously, John Calfan, my co-host, Bobby Nealon.
What's going on?
Today, we're here with Derrick Turks from Terminus,
That's right.
founder, CEO, and head honcho over there. How's it going, man?
It's great. It's good to be here.
Appreciate you
thanks for coming.
So we'll kind of jump in like we normally do. Just give us a kind of brief background. When did you kind of get into energy?
Yeah.
How did you, where'd you go to school?
Yeah.
What'd you study? How did that all kind of evolve to get you to the
Yeah. So my whole career path has really been the story of slowly kind of working my way back to what I always kind of wanted to do since like middle school or junior high. The oil and gas thing was a little unexpected. So my background, the resume version is I'm actually a mechanical engineer by degree.
Woo.
Went to University of Texas, hook 'em horns. But no, I kind of got mechanical engineering was a degree that you took because you didn't really know what you wanted to do.
It's the most diverse one, right? Or
Yeah, I mean, it was, the
anywhere.
pitch was you could kind of do anything, but in
Mhm.
practice, what that meant is you were going to sit in a cubicle and design
Design
sprockets
stuff.
for Caterpillar or whoever. My dad's a petroleum engineer. Actually, a lot of my family, both sides of my family, kind of have some oil and gas industry history. There's actually a cardboard cutout of one of my ancestors up in the Titusville, Pennsylvania, the Drake
Yeah.
well, the first
Oh,
oil
yeah.
well
I've been
in
there.
the U.S. So you'll see Opa Turk there. That's a
That's awesome.
ancestor of mine. So we've got some history there. But
Highly recommend checking that
yeah,
out if you're
it's-
ever in that area. It's not that far from Pittsburgh.
It is
It's worth the trip.
really
too.
cool.
Yeah.
Yeah. Percussion drilling. You think about that for a second. Like, holy cow.
You can even take home some oil from the oldest
Yeah.
producing well in the country. I've
Yeah.
got some sitting on my desk.
Yeah. But no, I mean, so I got into computer programming as like honestly a little kid, like
Yeah.
5th or 6th grade.
Like on Basic or
Yeah,
Yeah.
writing Visual Basic macros
Nice.
in Word, right? Because
Oh,
it
wow.
was, and this is how there's a whole. I won't go into this rant, but basically Microsoft kind of screwed everyone, for lack of a better word, when it came to learning programming. A lot of the PCs and kind of the prior generation, if you grew up 5 to 10 years before I did, you might have like a Commodore 64, and it would come with Basic pre-installed. It would boot into a programming environment. Windows was a lot more of a kind of a consumer device, right? Granted, with 20 years hindsight, it's like nothing compared to iPads and phones. But still, it was fundamentally not designed to nudge you in the direction of being a programmer. And so, as a kid, I kind of discovered this thing. I was like, oh my God, you can have a button, and when you click it, it's like guess the number.
Dust.
And
Yeah.
just really cool, really awesome games, right? I didn't have a Nintendo, so that was my
Your outlet.
cheap entertainment.
No, man, that's
And so, I kind of being in high school in the midst of, I guess, the dot-com boom followed by the dot-com bust. All the advice I got was like, oh no, don't study computer science. That's that's a dead end, that'll be over in 5 years. And so anyway, took mechanical engineering as kind of I didn't really know what the heck to do. Spent the entire degree trying to find ways to work kind of programming into that. And what at the time AI is this funny word, right? Because it's just always whatever's like 5 years out. So at the time, AI meant stuff like genetic algorithms and these wacky kind of global optimization techniques that anyway, so we played with a bunch of that stuff as kind of a hobbyist all through college, and ended up kind of, given the family history, I had a lot of people trying to persuade me that the oil and gas industry, or I guess what we now have to call the energy sector, is a good place to be. And took some internships, kind of enjoyed it. A lot of interesting stuff going on, a heck of a lot more than what was going on in the more conventional mechanical engineering world. Because it really, the comparison was like you were going to sit in a cube and be responsible for sprockets on this particular line of tractors.
Yep.
Versus, and I kind of was strongly drawn to reservoir engineering, where you sort of see this whole picture of
right.
these, multi-million-dollar operations start to finish, and the entire life cycle, these big capital projects.
It's
and
important.
And it feels like you're actually
Dynamic,
fundamentally
right.
producing, I hate to say it, but my wife, Catherine, also a mechanical engineer by background, also did something totally different, went into the chemical industry. We talk about making molecules, right? Like and it sounds weird because I'm on a tech podcast, and obviously we're kind of in a tech role. but I love the draw of working with people or working in industries that actually produce tangible stuff, right? We don't do a lot of that anymore in the US. That's as deep as I'll go down that rabbit hole, but there's a draw there for me.
It's true. I didn't take my PE exam because I was like, I don't want to go do that. I don't want to go design parts. And then if they fail, be out of a job for the rest of my life.
Right. Yeah.
I also didn't trust myself mathematically.
Oh my God.
That's a lot of stress.
Tell you this, differential equations pretty much ruined any dreams I had of becoming getting a PhD in Mechie or becoming that was.
I still remember the spring equation from Diffie.
Yeah. The really
the only thing I remember from it. Though.
Oh God. Yeah. Hooke's Law or, well, no, not even Hooke's. Yeah. Having flashbacks there. No, like no joke. One thing that really drew me to programming is all the math is, like there's no real numbers.
Yeah.
It's all integers. It's all discrete math. If there's like an alternate world where they taught kids discrete math in middle school, and I would have loved it. Like that just would have made math versus geometry, right? Or in calculus. But oh well, it is what it is. So those of us who can't do the calculus are kind of drawn to integers.
Yeah, it's funny because it's like it's one or the other. I feel like generally, right? Like I'm a very visual person, and I'm also I'm too logical at times. And so like if it's theoretical math where it's like prove this proof.
Yeah.
Why? Yeah. Someone else already did it. Yeah. I don't care.
Yeah.
And that was basically my college experience.
Yeah. Well, I mean that's that's what half of Cal and ME in college is just proofs.
Right? And derivations, just endless derivations.
And so it's like I was a C calculus student, but I was an A physics student using the same calculus, but it's just applied, and it's
I remember getting a kind of handwritten red ink note on one of my fluid mechanics exam that basically said, well, not basic, literally said, you do not understand the principles of Bernoulli's equation. And I was like, yeah,
you're right.
That's right. I don't understand this at all. So it was educational, but long story short, I kind of almost immediately discarded the degree other than as a kind of line item on a resume, and ended up going to work for Devon Energy.
Okay, nice.
First in Houston and then up in Oklahoma City later, and kind of found my way into being a reservoir engineer in their new ventures group, right?
Okay, so you were in the new ventures.
Yeah. And so so new ventures, this was like 2009, 2010, 2011. Devon was a little behind the curve on like Eagle Ford and in oil shale or unconventional oil in general. And so we were trying to make sense of this stuff any way we could, including through reservoir simulation, which really, I think about some models sometime where you had basically no data, and you kind of build this 3-layer cake and say, oh yeah, this is under this massive set of error bars, here's the massive set of error bars you get out.
It's somewhere in here.
Yeah, it's kind of a totally fruitless exercise. So what really started to take off is using more statistical approaches, where we started saying, okay, I have no idea what the actual mechanics of this rock are, or for that matter, even what the properties are, right? There's a whole, what is permeability in a shale? Well, let's see. We drilled this core from 10,000 feet in South Texas. We took it up to the surface. We put it on a truck. We shipped it to Colorado. They crushed it up. They put a transient pulse of helium through it and measured and differential equations comes in, right? So there's some fancy math with differential equations. And that turns into some number that they call system permeability. Right. You're like, I don't know what this has to do with anything. I can plug it in my model. But so anyway, we started taking the approach of, well, here's what I can measure, whatever that is, right? Whatever variables we had. Right. Here's what I care about, right? Which is like IP30 or 69, whatever, some short-term production data you had. And you just started looking for correlations, right? Throwing, whether it was predictive models or just sort of, things like clustering algorithms or any way to look for trends and patterns, or even very modest kind of leverage on the problem of, especially as you got farther down the life cycle into like frac optimization. And, we may not understand any of the mechanics going on here, but man, we see that there's we can get like never trust any R squared above 0.8.
Yeah.
Oil and gas. But we can get like a 0.72
right.
On this model. And if we kind of, hold everything else constant and lock in the average values for this reservoir, and we draw the response curve of like IP60 or IP90 or even 6-month cum if you live in paradise and have that. I can draw the response curve of that versus proppant loading, and hey, look, diminishing returns. There's some kind of S curve, and we want to sit kind of like right here at the elbow.
Yep.
So we started doing stuff like that, and it I was actually kind of the first staff engineer in Devon's. I don't think they call it data science. I don't know what they call it now, but basically data science team. It grew out of reservoir engineering for the reservoir engineering technology group that sort of supported new ventures is how all those initiatives started at Devon.
Interesting.
And if we want to kind of tie this into like history lesson of what tools you've used and so like, what were y'all using at the time to do some of that stuff?
Oh man, this is one of those that's going to get me in trouble because this is like the why did I go? Well, all right. So there's a great episode of Always Sunny in Philadelphia where they put on a musical, and this question keeps coming up of like who are we doing it versus, right?
Yeah.
So I'm that kind of person. I've always got to be, maybe it's weird, but my motivation is typically like all right, but who am I doing this versus? Like what's really kind of grinding my gears lately? So I'm not gonna name names, but a large 3-letter acronym statistical software vendor that I dealt with over the years provided very expensive tools, very expensive consulting around those tools, and to be honest, we were kicking the crap out of their results with free software, with at the time things like R, honestly, a lot of the R ecosystem, a little bit of, I mean, my God, what was it, 2008? There was probably Perl scripts floating around, a little bit of C++, Python, kind of a grab bag of everything, right? But, it was just kind of this shocking experience of seeing how industry was being, our industry is a little bit conservative for better or worse. And so we tend to be drawn to the big vendors, nobody ever got fired for choosing IBM type approaches.
100%.
But man, it was brutal seeing like how much and not just at the company I was at, but across the board, how much companies were spending on some of these big proprietary software packages, and then just like the quality of the output and the analysis versus what you could do for free, literally piggybacking off, obviously years of work by a lot of people.
Yeah.
But, it was incredible. And so, that one of the big factors in kind of realizing in 2013, I could kind of jump out on my own. And there was this need in the industry for, the logic at the time is there were obviously a lot fewer people who could do kind of what we call data science or analytics or whatever the buzzword was. It changes. And had the domain knowledge of oil and gas versus even what the big, software vendors or IT consultancies could offer. I mean, there was such a shortage. And of course, this was, I think I've got a slide in a talk I've given a couple of times that shows like the Google Ngrams trends for like data science versus time. And of course, 2012, it just like shoots up because it was, Harvard Business Review.
And the Times had the whole like sexiest.
Right. There was this article about, I think they called it analytics or whatever, but Tom Davenport, and then Moneyball blew up, and you had all these things kind of kicked in at the same time. And it suddenly became like all anyone was talking about. Yeah. Sexiest job of the 21st century. And then that guy went on to actually become the U.S.'s, the first official like U.S. national data scientist right under Obama. It was this whole PR. I mean, anyway, so it obviously the timing was right, and I kind of jumped out and, I was kind of liken it to like building the engine as the plane is in flight. But that's a
very good analogy.
So that was Devon into just on your own, like
just jumped out on my own and went out independent. It was just me for many years, and my wife Catherine actually joined the company in 20. Well, this is terrible now. I don't remember.
Last couple of years, right?
21. Yeah, it's been about 2 or 3 years. Again, coming from the chemical industry and kind of having some experience in things like predictive maintenance, and there's a whole other world of like things we can learn from in our industry that people have been doing in these kind of very companies that we tend to think of as kind of boring or conventional. But you look at your
lean manufacturing, right? Like,
exactly.
Literally the simplest shit. Right? Like I was doing this as an intern in college, and when I was an intern, it was 30 years old.
Yeah.
And then I'll never forget when I saw the article in the Chronicle, about Hess announcing that they were implementing lean manufacturing methods in like the mid, whatever, 2015, 2016, something like that. I was like, this is 40 years old, guys. Like, why is this front page worthy news? This is not a new thing.
I've been in organizations where, there's a Six Sigma, a new exciting thing that, like he says, been done since the
Toyota's been doing forever.
Yeah, we're finally kind of catching up with the hottest trends of the 80s.
Yeah, right.
What's going on in Japan is really interesting. We really need to look into that.
No, that's
well, even like Agile and all that. I mean, it's like the Agile Manifesto was however long ago, but then we could probably even get into a whole how it's probably not the best workflow for data type projects.
No, there's a whole conversation about what even is Agile.
Yeah,
if
you just doing Scrum every day, right?
Yeah, exactly right. Like any, well, that's a whole. Maybe I won't say that on air, but there's like a lot of movements in history when you look at what the original founders intended versus kind of what it got turned into. It's like, oh my God.
Very true.
Yeah.
So, I mean, one thing I wanted to kind of hit on, and people may or may not be aware that this was you, but there's the ArpsDCA package. Was that at Devon? Was that once you branched out?
No, that was something. And to be honest, I don't even remember what. I think that spun off from a project we did where we kind of, ended up having done a bunch of analysis. We by necessity built an R library for fitting ARPS declines and said like, well, this would be a cool thing to open source and kind of use as both number one, so people stop reinventing the wheel, right? Because so with a little bit of boring history, but at the time Spotfire was, probably still is, but was kind of the BI tool that had taken a hold in the oil and gas industry. And Spotfire went for a long time had no real programmatic interface beyond Iron Python, which you could actually sort of we had tools at Devon.
And what S+?
Well,
not even at that point.
I think they had an external interface to it, but it was pretty obscure. Like
because I started with Spotfire 2014.
Okay, yeah.
So like at that point they had S+, and I think Terra was in its infancy. But
so at Devon we had I remember this project. We had I built a random forest model for frac optimization, like I think it was in the Barnett Shale, and what I ended up actually having to build is kind of I'm going to say, for lack of a better word, a compiler that would translate that generated random forest model. In other words, those tree, kind of the decision tree, right? The kind of if thens in the random forest to Iron Python code that we would then run in Spotfire so that we could actually embed the model. And of course now, they've got TIBCO, for whatever reason, decided the real way to open up custom code inside Spotfire was to sort of white room implement R odd choice, given it's already open source, but whatever. I think they wanted to own it. And so that was Terror, which is kind of this almost compatible re-implementation of R. And now so you can write R code to implement sort of custom calculations inside Spotfire. And that took off about the time we released ArpsDCA, because people started asking like, oh, cool. Like if we have R code to do this, we can run it in Spotfire. And so, all right, well, put that out, and that's kind of what made that blow up. And people, it's really funny. Like I've had the experience multiple times of getting an email, in my capacity of as Terminus, let's say, that's like, hey, we've been using this R package called ArpsDCA, and we're looking for someone to help us integrate it with Spotfire. And then every once in a while, I'm just like, look at the author.
Yeah.
The author tag on the. Yeah, we can help.
I think I can help.
Might be able to help you with that. Yeah.
I think I'm fairly familiar with that chunk of code.
Yeah, it's funny how some of that stuff wraps back around when you publish code as open source. It's funny.
Are there still commits and stuff to it?
Every once in a long while I'll take a bug report or something. I don't think we've made meaningful changes to it in years and years.
I mean, the ARPS equations haven't changed.
Yeah, the ARPS equations haven't changed. I'm not saying it's kind of perfect or flawless, but it's, it seems to do what it's intended to. And we don't do a lot of R work these days. I don't think the industry, it all comes back, like in our industry, it all comes back to Spotfire. So as soon as Spotfire opened up the ability to write data functions in Python, that kind of, R's lost its luster a little bit.
Yeah, and I think we were kind of talking about that the other day on the upstream Slack channel, just even about how R, and then now there's Julia, but it's a matter of like, well, is it too late to the party? And there are better options. But I mean, like, I personally love R. I mean, as far as like, I would like to use it more, but then there's still this whole can't use R in production thing, and there are limitations to it. I mean,
I have such mixed feelings because it's an interesting specimen as a programming language. Yeah. It's not a good programming language, but it's a really interesting one when you put it in context of sort of like, what is it really? And that's probably for a different podcast, but it's a living fossil. It's actually kind of in the Lisp family of languages, and it's actually obscure even within that because of the way it implements Hadley Wickham would call it lazy evaluation, but what it really is like this other thing called F-expers, which is, there was like one researcher that was into this and he's dead, so it doesn't. Anyway, like I said, topic for a different podcast. It's kind of a coelacanth. But the thing that R, so I'm also a believer in like don't use R in production, and for me that comes from using R in production, and just
not
discovering
like good testing
some of
suites and
it's
not like Python's great either.
No,
but it's more robust.
I've got plenty of gripes on Python, but there's also kind of it all comes back to fashion and network effects, right? And it's like there's safety in numbers. The thing I miss from R is actually the graphics, right? The plotting.
Yeah.
We mean my wife and I were talking about this the other day, as one does at Terminus HQ, on just how there's in our opinion, there's really no nice, easy to use sort of JavaScript or web client side graphics library that produces good output out of the box, right? And I know people write in with, they're like, oh, high charts, Plotly, yeah, whatever, I know. But but you got to remember, I'm comparing to like ggplot2 and R graphics, and just like, I don't think people who didn't use that understand how easy it was to just say like, I've got this data frame, hey, show me EUR versus lateral length, but break it out in panels by landing zone.
Yeah.
And it was a one-liner, right? There was kind of this domain-specific language for it.
You have to have all the setup for the plot and all
I think there's someone trying to implement grammar graphics for Python. I
think that'd be great.
But I mean, because the one thing I liked, you talk about like for the web, client side, I loved in R, then the Plotly package, you could do ggplotly and just basically plop your ggplot code inside of that wrapper, and it would just turn that into the interactive web version too. So
So I don't know. We were big D3 fans, and I think the monetization story there with what are they now? Observable HQ, kind of the notebook. They'll let you use D3, but they really want to sell you a subscription to their cloud-based interactive notebook thing, and it's made the documentation just completely unusable, in my opinion.
I'm kind of in the same boat with you. My favorite thing about R versus Python, generally speaking, is the RStudio IDE. The variable explorer and the plot. Like, as an engineer, I like to, and just generally speaking, as a visual person, I like to be able to see, okay, as the code runs, there's my variables come popping in, and what is the value of said variable, instead of having to put print into my Python statements.
And I think we talked about this before too. Like the REPL is like a huge deal, and that's why notebooks won't die. And that's what I mean. Like there's
and REPLs are so interesting to me because like all right, we'll go into a little bit. So
let's go into it.
R is literally, it's kind of descended from the Lisp family of programming languages. And so a lot of, if you kind of don't know what we're on about, there's this idea called a REPL, read, evaluate, print loop, or an interactive interpreter. And it's kind of the thing you can do in Python or R, or I suppose JavaScript if you drop into just like Node from the command line, where you can enter one line at a time or one statement at a time if we want to get real technical and have it evaluated and sort of see the result. And if you're coming from something like Java or C++, obviously it's like, oh my God, this is interactive. This is really cool. I don't have this compile step in my loop. But I think people have, the generation that maybe started with Python or JavaScript doesn't really know the limits to which you can push that. And so Lisp, the Lisp family of languages, in small talk, I would put in kind of a related category, really played with the limits of what you can do with interactive development. And so like if I'm in a common Lisp environment, and I have been once or twice in my life, sort of like you said with RStudio, it's not just, oh, I'm entering a line and seeing the result. It's like, okay, I've got my source text over here, and I've got kind of a running, REPL over here. And then maybe I see this variable in my source text, and I'm going to hit a keystroke, and that's going to pop open an inspector, and I can see, oh, it's an object of this class. Okay, it's got these elements. Well, let's zoom in on that. Show me what the, what the monthly production field of that is. Oh, okay, that's an array of floating point numbers. Oh, oops, that one's wrong. Let me edit that. Yeah. Okay, I'm going to call a function on it. That crashed. Oops, let me go and edit the code of that function. And so it's kind of, this environment where everything could be sort of explored, almost like hypertext, right? Or like a website where you could navigate between data elements in the running program. And sort of interactively edit source text. And it's a totally different way of working, right? Like even the Python REPL or notebook is still very much it's like the butterfly that's been kind of pinned to the board and preserved, right? You can see it, you can kind of play with it, but you're not seeing it in action. You don't really have, you've got kind of static snapshots at points in time, but you don't really have the live object. And so that's, I completely agree. People who haven't worked in an environment like that.
It's rather like VS Code though now, because you can run your Iron Python notebooks in VS Code, but then you can also have like the variable explorer. So
I would love to see more hooks, and maybe the Jupyter people will kind of build in that direction. There's no reason you couldn't on top of Python. It's the interpreter's got all the hooks to kind of introspect objects at runtime.
Yeah. But, well, it's just like, I feel like with some of those languages, right? You've got people like us who weren't necessarily trained in coding, but are very logical and understand logic and math and like coding. And so for someone like myself, being able to go through essentially line by line and kind of debug and see how the logic works and see what is in which variable at what time and figure out why it's not working is a very helpful thing.
Yeah. And I like the REPLs from like, especially if I'm working on something and I don't know what I want yet, but I'm getting it from an API.
Right.
Like, I don't want to hammer that API every time I need to run the code, or save it to a JSON file and then write some subcode to go, I can just store that JSON object, or even a data frame of that or whatever. And then I can iterate on that object from that step rather than having to re-pull it every time.
So I think our industry is actually really lucky in that we're a little bit slow to adopt things. I say this is probably me just rambling about a current project. For those of you who've never had to deal with this, how fortunate we are that our industry didn't really adopt web APIs until things have become predominantly JSON based. I'm going to put REST in massive scare quotes because there's this whole holy war over Roy Fielding's thesis and what really is REST. And basically my card's on the table. I think the original definition of REST is kind of dumb and useless, but like if you treat it as RPC over JSON, like RPC via JSON payloads over HTTP, like I think that works great, which is what we do anyway. So the real thing is, had we gotten started 10 years earlier, everything would be freaking XML and SOAP. And I'm working with a financial client, a financial industry client right now, and it's like, they were earlier adopters. Like, oh my God.
Yeah.
I think technologies rise and fall basically proportional to how hard is it to figure out what is going on when all you have is a crash dump and a text editor. And with JSON, that's a heck of a lot easier than it is with SOAP. So that's kind of my theory.
I've had to touch a couple XML evolution. Things at different points, and it's like, why? Like, this is awful.
It's funny because it's like the concepts behind some of them are really good, right?
Yeah.
Like with XML having structure and naming conventions, and it's always in this format and this structure. But then it's like, you get into people and they're like, no, it has to be this. It's like, well, I could just replicate the database to your database, and you actually have way more. You have the same data in a structured form where you don't have to write a bunch of code to ETL it the way you want it. But
I think there's a whole through line between let's see, some odd touch points I think kind of triangulate what. All right, it's high modernism. There's this guy James C. Scott. He's a anthropologist, historian, anarchist, a little bit of all three. He's got this book called Seeing Like a State. And it's kind of this is, I promise there's a point to this. It's kind of this critique of how in the 20th century, well, actually not just the 20th century, but it took off in the 20th century. The world saw this kind of wide spectrum of programs and policies that took the approach of like, we're going to have the perfect design top down, modernism, right? High modernism. Le Corbusier designing cities that were these perfect geometric grids, or the Soviet Union coming in and collectivizing farms and trying to put a rational 5-year plan on them. And I think there's just kind of this, there's this human hubris we have of, sorry, this is I view XML in the same. XML is like the WinXML thing is the same category to me. There's also a Richard Gabriel essay that has to do with Lisp versus C called "Worse is Better," and the punchline of all this is like, often in some field of human endeavor, there's kind of two approaches. One is smart guys sit in a room, think of all the cases, and write down the perfect, flawless, shining crystalline gem of a plan that's going to encompass everything. And the other plan is like, let's just let people do their thing and see what happens, right? Let whether you call it evolution or the free market or whatever you want to call it, but this idea of let's just let things kind of compete, naturally work out, and systems designed along the second, and design may even be a misnomer. Systems that come about through that kind of organic evolution seem to last a little longer, be a little bit more robust.
I mean, you look at all the open source stuff, all the languages, like
even
Bluetooth, Wi-Fi, like
they
were
Bluetooth,
organized,
but
but they're still mass, like built by
right. The other classic essay would be The Cathedral and the Bazaar, right? Eric Raymond, I think in the 90s, had this kind of take on the development of Linux versus kind of proprietary software, and this idea that maybe for some things it makes sense to have brilliant people sit in a room and build their flawless architecture, but for the kinds of things that have to interact with a lot of different edge cases, you do a little.
But then you have, it may be flawless, but then it's flawless based on their biases. And
it's this thing that's perfectly crystallized to their
what they know,
their biases, what they know, their
what they can anticipate,
they accounted for,
right. It's going back to Lisp. Lisp keeps coming up, I guess. It's kind of a cultural touch point in programming, but Common Lisp it locked in all the best ideas of the mid 80s. So you've got this vast kind of standard for everything that should be in the standard library and how things should work, and it touches on all these concerns that were really pressing at the time, like the different is my character set ASCII or EBCDIC or whatever, and then of course it's like, but what parallelism, concurrency, like that's not in there because
it
wasn't a thing. So there's no
I think that it's a good point. Things have to be able to evolve if they want to have sustainability.
Yeah.
They can't just be completely locked down without any room to grow. I mean, that's what you see with all the big companies, right? It's like they round up a bunch of really smart people and then they put all these handcuffs and constraints on them and bureaucracy and IT, permissions and all this stuff. And then they can't really grow it and evolve it like it should be if it was just open to them.
So kind of moving back a little more towards Terminus, so is it mainly like a lot of projects, or do you guys have any products?
So we're like constantly 1 year away from a product.
Yeah.
And we've looked at a few over the years. The bulk of our work is consulting, and we've kind of, I guess the interesting story is when we started, we were Terminus Data Science LLC. And of course, data science was, sexiest job of the 21st century. And if anyone remembers that time, there were all these great Venn diagrams about data scientists being a unicorn, right? You had to have, I think one was domain knowledge and statistical knowledge, and then programming or computer science. And then the intersection was data science. I thought, that's great. That's exactly what we do. That's so true. If someone's got that intersection of skills, or an organization does, they can really come in, they can make a big impact relative to their resources. You kind of this high leverage kind of approach. And of course, I don't, I've got a talk out there somewhere. I've given variations on a couple of times called like Save the Unicorns. I think we did this at Saga Wisdom, Sokva Becker last year. And the premise is that somewhere along the lines, we got kind of caught up in trying to be Google or Facebook or emulate what was coming down from these massive Silicon Valley tech companies. And we sort of let that role of data science become this super specialized, siloed thing. I'm going to rag on data science because I see this on LinkedIn all the time. I've probably seen 3 posts in the last week that boil down to like, companies need to invest in data pipelines or data engineering because otherwise the data scientists just don't have clean data to work with. And it's like, guy, I don't know what you think your job is, but that's what, I'm sorry. If your role is to take pristine, normalized, flawless, well-defined data and plug it through, I guess, AutoML and then say, hey, boss, the R squared is 0.72.
Yeah.
What?
I can get software to do that.
Like, I'm not a big, I'm kind of an AI skeptic. I don't think ChatGPT is going to take our jobs anytime soon, but that guy, I don't know. It may take his job.
Yeah.
That's not much of a To quote the consultants in Office Space, I mean, what is it you would say you do here?
Yeah.
Because I think that thing we call data engineering is actually closer to the sort of the spirit of what data science originally was, or at least a big piece of it. We kind of have this tendency to want to call things data cleaning, or I always, in programming, we call it glue code, right? Which is, I suppose, if I were fancy, I would say it's ETL or maybe ELT.
Right?
On how someone will eventually clobber me over the head hard enough I understand the difference there. But it's
the
all
letters are arranged in a different order.
Right. Yeah. So right.
So they're different.
But fundamentally, I don't know. Maybe I have this archaic belief that a data scientist, or let's just say a person in that kind of hybrid role of domain expert with some statistical and software chops, it shouldn't be that big a deal to, say recode missing values in a table, or write a little bit of SQL to join two sources, tables, or it's not. I'm not trying to belittle it. It's actually, it's foundational, right?
Yeah.
It really, if you can't get that right, I sort of question.
I think that's where a lot of people have the problem, right? Is the sexy thing,
right?
Is the end result?
It's like
it's
right. 10% of the job,
right? But yes, I completely agree with you. The minute you start going down that rabbit hole, even as a hobbyist,
right?
Like, oh shit, I've got this API from this JSON. Now what?
Right.
Or like looping through a JSON.
But getting back to that Venn diagram, this is supposed to be the person that has the domain expertise. So you should be able to look at that data and say, this data is not right. Or I should be, these are bad values I shouldn't kick out.
For all I complain about, they can't write SQL, which is a valid complaint.
Yeah.
But what's scarier is kind of taking the domain expertise out of the loop. I see data science becoming treated more and more like an IT function, and it's data comes over the fence. I won't name names, but it's like, I have been in conversations where the data science team have been asked to forecast production. And so they, went down all this rabbit hole of time series models and ARMA and Arch versus GARCH versus, and it's like, okay, but have you looked at ARPS? What's ARPS? It's like, let me give you a citation from 1945.
Yeah.
And I'm not saying ARPS is the end all of BLF forecasting. What I'm saying is, if you're coming at it from the angle of ARPS doesn't adequately capture the transient behavior of unconventionals. Yeah, I totally agree as a reservoir engineer. If you're coming at it from an angle of,
I'm going to take time series data.
It's just a generic time series, and it could be widgets sold per quarter, or it could be, maybe not. There's a different set of physical phenomena behind.
Well, it's not seasonal. It's not
right. Depletion drive is a little bit different than like seasonal trends and babies being born and how many diapers people buy as a consequence. Different mechanism, right? So we've kind of de-emphasized the data science in our branding, just because we're kind of not the prima donna that's going to come in and say, I don't have. So and we've also discovered over the years that there's a lot of need for automation and custom software, and I always tell people, because there's this whole argument of build versus buy, and there's no right answer. But what I do tell people, and it's a little bit self-serving, but it's also true, or I believe it's true, is that if you are, say, an EMP, or you're an engineering consultancy, or you're a trading shop or a PE, whatever you are, if you've got some process you've designed, and if you really believe there's proprietary advantage in that, and you should, right? I mean, that's kind of your thesis if you think about it. There's pieces of that it does make sense to build versus buy. You're not going to get that off the shelf. Right. So a lot of what we do is come in and help find that. Maybe 5 or 10% of the overall process that really is core and special and proprietary, and turn that into sort of robust software that makes it a repeatable, automatable, production ready process.
Yeah. I think that's a big thing for me too, that, just getting into this over the years started out more as a hobby, but then became my job to a certain extent. You start to realize, right? It's like, you get so excited the first time you run whatever script or model or whatever locally on your in your IDE or in R or whatever, and then you're like, okay, well shit, how do I get this so I can have it customer facing? Like, oh, that's a lot different.
It's hard.
Right now, you've got to spin up back into architecture. You've got
and it's gotten
there's UI UX.
The more that we sort of chase the kind of what's coming from Silicon Valley. I mean it. Google has a certain scale they operate at, and they have a certain base of talent that they draw from, and they have I mean, literally just an army, right?
Yeah.
Like there are, Google has more programmers. I'm like thinking about to my like Persian Gulf War stats. I'm like, oh, I don't know what rank they would be on the list of like largest armed forces in the world. But if you armed every programmer at Google, they would be in the top 10, right?
Yeah.
Like they would compare favorably to a lot of countries in the world, just in sheer head count. And so, the kind of process that makes sense when you need to make an organization with literally, tens of thousands of people sort of function in a plug and play way.
Very different.
There's trade-offs they're going to make that don't make sense when it's, 10 guys in a server in the closet.
Yeah.
And that's not to knock the 10 guys in a server in the closet. That's actually a lot of my favorite clients are kind of at that scale. But probably launching like a Kubernetes cluster on AWS is not going to be the cost-effective way to help them achieve their goals, right?
Site.
And so it's exactly. So there's there's just kind of like a scale awareness that we've got to build in the industry.
Yeah.
So what are some, if you can speak, however much you can speak to it, but what are some of your favorite projects you've done? And then also, what are you guys using? I know you've started using some Rust lately, but is it a lot of Python?
What tools, what databases,
so we
services,
we do a little bit of everything. My like general advice on databases is I'm going to hang some asterisks on this. I'm a reservoir engineer. I work in most of my clients are dealing with, maybe production data, maybe daily or monthly financial data. What I'm really getting at is we're not dealing with like 3D seismic. Okay, I'll caveat it with we don't have some of the super high volume geoscience stuff. But man, in our industry, like it is shocking to come across a workload you can't handle with Postgres.
Yeah,
and I love Postgres. I mean, obviously we've got a lot of Microsoft heritage in the oil and gas industry, so you find a lot of like SQL Server, and that's fine. But man, SQL Server with its, kind of its geospatial stack, or Postgres with PostGIS covers so many of the needs of what we have in the industry. And people will, another fun like ETL versus ELT. The other one I can never remember is OLAP versus OLTP.
Yeah, right.
And in my head, it turns into like, because but I translate it to like row oriented versus column oriented, because that's what people use it to mean in practice. But for most of our workloads, like it's a distinction that doesn't really matter for a lot of what we do.
Well, that's one of the things I'm learning as someone who hasn't ever had to set up any kind of back-end infrastructure. It's like use the tool that makes the most sense from a cost and functionality standpoint that you've got at the time. Hopefully you can also try and forecast out what this will be a couple years, but there's also a chance that there might be something that comes along that's better and cheaper, or
and you want to design to be
your
portable too. Like,
that's I was just gonna say, like it's you can't plan. You don't know what's coming, but you can plan for how do I build this in such a way that I'm not hooked to super specific features
this
of
cloud
this
vendor, this
platform,
database,
exactly. And that's a huge chunk of. So our kind of talk about favorite projects, like we're in an odd niche, and that a lot of our clients do not even have necessarily an IT department. We've got a lot of clients that are small EMPs or maybe small consulting firms, might be like a PE shop or a non-op.
I assume that makes it easier sometimes.
Yes and no, right? So it kind of like talking about the modern data scientist and how it's very much like, oh, please spoon feed me like perfect data. I think those guys would come in and be totally lost. But for us, we find a lot of our clients don't necessarily have, they may have IT, one or two people in house, or maybe a contract shop that helps them like, manage kind of the traditional IT stuff of like keep the email server going and, Windows logons. But a lot of what we do is greenfield, but it also is greenfield in a way that like, we know we've got to leave something that requires minimum maintenance.
Yeah.
And so that what's funny is it actually nudges us away from a lot of what's popular right now. If you look at things like Python, a lot of pros and cons to Python, but pragmatically, one of the big issues with Python is what a pain in the butt it is to package up a Python sort of program with its environment, right? With its dependencies and with all the. And so there's 10 different mutually exclusive approaches people have come up with to this. And, I think what we've kind of standardized on, we being the industry, is just like slap it in a Docker container and ship that. But then you're trying to explain Docker containers to the IT guy person, and it's like, so it actually nudges us in some cases toward things that are like, statically linked compiled executables, right? And that's so like come back to Rust or even C++, there's cases where it's like, hey, I can leave you this executable and it's going to run for the next 20 freaking years.
Right.
Yeah.
And as long as I get it right, as long as I get it right the first time, there's some value in that.
Yeah.
We kind of build in ways that are a little bit different than what you do if you have a full sort of, what's the buzzword, DevOps type team, or things like that. Yeah,
an existing tech stack.
Yeah,
it's beyond the email servers.
So we talk about favorite projects. Like again, this has been like the 20-year journey of like, how do I finally get back into the thing I always kind of wanted to do, which is sort of like programming for its own sake. Some of the most interesting projects I think we've had actually are kind of these weird cross-disciplinary ones where we have a very industry-specific problem, but there turns out to be sort of this other lens you can look at it through that looks a lot more like something else that say we've known in computer science since the 60s or 70s. And like one that comes to mind is how many problems actually turn out to be sort of language problems, language translation problems, or maybe better put, like how many tools that we need for a lot of different random stuff look sort of like compilers if you squint. And so I've worked on some of my favorite projects involve like, hey, translating Aries lines to, production forecasts. And when you get into like the fact that Aries economic lines are really kind of their own programming language, you end up building, literally a parser and something that is kind of like a tiny compiler that, translates from Aries syntax trees to, whatever your output is, or this. So I guess I'll pitch our product. It's like constantly 1 year from coming out, which is this thing that grew out of I have a friend of mine is involved in SPEE, the reserves guys, Society of Petroleum Evaluation Engineers, right? And they were interested in a talk on Monte Carlo methods and sort of, so I gave one back in, I think it was February of this year on, maybe it's been longer. No, God, that was February of last year. Sorry. There's been a whole toddler in between. So that's like, brain's kind of
black out.
Yeah. But so the talk I gave was on kind of pitfalls of Monte Carlo and how, especially in petroleum economics or reservoir engineering, some of the things we often tend to miss, like, correlation between assets or outcomes and things like, modeling the decisions you're going to make in the course of a project. And along the way, I kind of discovered like, oh man, I really want to make this like an interactive show and tell. I looked at Crystal Ball, I looked at risk. I was like, okay, this kind of sucks. Like this is ugly and slow. And so I guess I, for whatever reason, had a lot of time on my hands the weekend before this thing. And I actually ended up building like a kind of a Monte Carlo modeling language, probabilistic modeling language prototype with, kind of like we talked about the difference between a REPL and like a truly interactive shell. And so it's got this interactive GUI where you can, for every variable in your model, you can look at the univariate or bivariate stats and see all these plots on the fly, and it's fast and yada yada. So I've been slowly trying to turn that into a product for a couple of years now, and it just, I don't, in the consulting world, everything's very
time sensitive,
interrupt driven. So
well, and the business is good, then
it's kind of this catch-22 of like you actually all your product work ends up kind of happening on like bad years. So by definition, but no, that's something we're looking at, and probably I've said this with a caveat. I've said this.
That'd be industry agnostic. Like, that's more like just some money.
So what we really want to do is build in the kind of the primitives, right? Like the distributions and the operators and the features that would make it very attractive for building sort of simple, quick look petroleum economic models. And what we have in mind is kind of like, so it's kind of around what is hard to model in some of the existing tools. Right. And that's things like, hey, I've got a pilot program, and if the pilot exceeds this threshold, I'm going to move on to appraisal. And if that exceeds the threshold, I move on to development. Okay. And hey, also, like, because these are all drilled in the same basin, like there's going to be a correlation between my pilot, right? Like the wells within my pilot and wells within my appraisal. And it's just, I'm not saying it can't be done, but it's somewhat challenging to model those in the tools that are out there. And, and so, and if you don't model them, you end up sort of, well, it can go either way. You can end up lopping off a lot of upside because you don't recognize that. Actually, that's the incorrect way to say that. You can end up failing to lop off a lot of downside because what you've modeled in is like a program where you're hell bent on drilling. And so if you don't build in that exit gate after your pilot, you suddenly your economics look terrible because you've said you're going to go full steam ahead no matter what.
Right. It's like the assumption that, hey, even though we drill this well, or like if the well produces 0 barrels of oil, we're going to continue drilling for
We're just going to keep throwing
I've never
money
thought
down
about that with the Monte Carlo stuff because I mean that's I worked for BASIP for a very short period selling their reservoir modeling or reservoir sim stuff and basin modeling stuff, and I found that fascinating how many knobs there are to tweak to turn on a reservoir model, and like it just overwhelmed the shit out of me because it's like this is just on a single well, right? And it's like now we've got hundreds of these and a producing field. Like you've got so many there's so many variables on just a well, right? Outside of all the rock shit, which but then you start throwing those in, and we've seen so much over the last decade of like this evolution of like frac hits, right? And how the actual operating activity is affecting your production and your new stuff and your old stuff, and like it's all one giant system ultimately. And so that's really cool that you're looking at being able to put in those because it's reality. Right?
Like, and you're not going to go
drill 100 wells if the first 10 make 0.
Right. and then like cynically, I mean, like the only problem with any probabilistic modeling exercise in the oil field is we quantify all these because we're reservoir. Well, I'm a reservoir engineer. I've worked with reservoir engineers, and we have some intuition or some idea for how to quantify the uncertainty. Like, well, I think the distribution of porosity might be this, and I think the distribution of permeability might be this. And we're going to build up these 100 variables and simulate the thing out. And then it's like, okay, we're going to slap 3 different price decks on it.
Right.
And it's like, $20, $50. So the financial, the fiscal and regulatory, and I think that uncertainty kind of dominates, and there's not a nice way around that. Or if there were, I'd be a much wealthier man. A very different place. Maybe there was a renaissance or some of the quants that think they really cracked the code. Anyway, I don't know. Maybe they've got it, but we want to kind of make it easier at least to quantify the uncertainty that we can't quantify.
No, that'd be really cool.
Well, just having a process or a model that represents more of a realistic scenario, right? I think that's anybody who has ever used any kind of model, whether it's reservoir simulation or any of the stuff that we did in college, right? It's like a model is a model, right? It's only as good as the inputs, and it's only a model. It has to account for all of the variables.
Wrong, but some are useful.
Right.
Correct. Yeah.
It's just how good at being right sometimes are they.
Ultimately. That came up so much in data science projects too. Is like people fixate on R squared or accuracy, and what you really, the accuracy is always kind of bad, right? Like there's so many unknowns.
It's a directionality, almost
subsurface stuff, especially. So right, exactly. So what we were always trying to push people toward is, well, all right, the accuracy is what it is, but let's use this to build some intuition on what drives what, right? Like I've got X1 through X10. Let's pull out X3 versus Y and see what that incremental, or marginal.
And then it comes down to also there's the explainability side of it too, like where people can actually understand what the hell's going on. Like a linear regression is way easier for someone to look at on the thing and understand. Like and maybe your deep learning model might be more accurate, but like no one knows what the hell it's doing.
Right.
Like
can't explain.
So if it's within a certain error margin, like use a linear model because people can look at that and like understand at least intuitively what the
that's don't sleep on those simple models either, especially for BI stuff, right? Like I worked at a company and I started playing around with some of the Python I think it was, or not Python, in Spotfire, some of the regression analysis and stuff that's built in. And, I was on the sales side at the time. And so I was like, oh, let's throw in like oil prices, rig count, completion, like all the permits. I threw as much stuff in there as I possibly could. And guess what? The biggest impact, like 80+% on our revenue, was oil price. And it trailed oil price by a quarter. And it was perfect. Like it's a great linear. But had I never done that,
and the Pareto principle,
and I thought it was going to be this like, oh, well, it's going to be based off rig count or permits or whatever. It's like, no, it's
that drives all those things.
Right, exactly. Like
there's so many things in our industry where if you can kind of transform the variables so they play nice with linear models, or I also like random forests and kind of decision tree models because they've got some of the same flavor, but you can show a
there's a flow chart. Here's how it works through.
yeah, it's amazing how we seem to want to jump to like the most complex possible thing.
Yeah.
And yeah.
You also have to be comfortable just like knowing that, hey, there are probably other factors in this, and I need to be cognizant of them, that I might not be taking it into account with this, but for what I've got, this is the best representation of it, right? It's never going to be perfect.
Right.
Cool. That was a quick hour.
Yeah, no, goes pretty fast, man.
I feel like
that was very quick.
Yeah,
this has been really good.
Yeah, but we usually end with like a kind of a lightning round. Just
okay. Yeah. Oh, I love it. Yeah.
Try to keep it at one word, but sometimes
short
you can't.
sentence.
Yeah.
I'll jump in one. Who's one of your favorite or biggest kind of influences, either in general or in the tech space, or
Edsger Dijkstra.
We can say oil and gas space.
Tech, Edsger Dijkstra, first Dutch programmer. Was a professor, kind of mathematician turned computer scientist, and you can look him up. He's got a lot of really great kind of grumpy old man.
No, those are my favorite.
A lot of things.
Is he active on any kind of like social or anything like that? He's dead
years ago.
Okay,
yeah.
What's your favorite open source tool, or
Vim?
Vim. Okay.
Yeah.
What is that?
It's a text editor. It's a 70s text editor.
Is that the one that I might have found or used?
Maybe. I mean, you may have been stuck in it because you couldn't exit it.
Yeah, I live in.
No, like you have to I forget what it's like QI or like there's like
colon Q or I think you can do
exclamation
capital Z. Or,
I don't know. But I have to look it up, but it's kind of like a meme at this point, like how to exit Vim.
What is one of your favorite books?
Ooh.
Both in general and tech related, or engineering related, either one.
Okay, Moby Dick. Everyone should read Moby Dick, but tech. Oh, that's actually a challenging one. It's like I'm trying to.
You can give a couple.
Like design. I'm gonna.
You can't narrow it down. It's hard.
Yeah, I don't know. I'm gonna punt on that one. I know it's terrible, but I'm kind of drawing a blank. I'd say there are reference books I come back to over and over again, but a lot of them are like Types in Programming Languages, Ben Pierce. But if you go on my GitHub, you'll see I have weird hobbies. So some of these answers aren't gonna necessarily make sense in our industry.
No, that's why I love. That's why I like it.
Yeah. What's your favorite like managed service?
Oh.
So you're heavy like coder type.
Oh,
so
God. I try to avoid them. I run Linode. I've had good luck with Linode over the years. For our servers, they just got bought out, I think, by Akamai. We'll see how that goes.
Okay.
AWS confuses and frightens me. I love Terraform for one reason, which is I don't have to know AWS CLI. I can just kind of like have but I also try to avoid being in a situation where I need that.
Right. That's true too. What's one thing you could nerd out about and spend hours talking about?
Oh, I mean, a bunch of things.
Besides the
tech, maybe something outside of tech.
Reservoir engineering.
Oh, probably like military aviation.
Okay, cool.
Scotch.
Cool. Yeah.
Scotch distilleries. Scotch distilleries
That's a good one.
The islands off the coast of Scotland.
Nice.
That's perfect. I'm right there with you on the whiskey side. But make a prediction of what the future of energy or energy tech looks like in 10 years. What's one of the biggest impacts you think that's coming down the pipe in the next 10 years?
In energy specifically, man, I hate making predictions about the future.
The beauty of it is that no one's gonna hear this.
You're data science, right? You should
maybe this is more of a hopeful prediction.
What does your linear regression model say?
I think what needs to happen is we need to pull data science, data analytics, data management, even to an extent, back out of being seen as kind of an IT function and pull it back into being a core engineering or business or basically see it as a profit. Not only see it as a profit center rather than a cost center, but also the people managing that and frankly the people doing that work day to day need to be the domain experts, not kind of so I don't it ties into longer term like predictions about, well, is the tech industry kind of in the middle of as we are going to learn what's Warren Buffett's saying, like when the tide goes out, you're going to learn who's been swimming with no pants on, right? So like as we kind of come out of a zero interest rate environment and venture capital gets tighter, I think you're seeing contraction in the tech industry. And I think that's going to drive some people to look elsewhere for employment. I think we may pick up some talent from that, which I think can be a good thing.
But you have to upskill them on the
But you've also got to bring them in as domain experts, because the last thing we need is a bunch of ex-Googlers coming in and saying, oh, I know what y'all need.
Yeah.
A freaking Kubernetes cluster. When the real problem is like, man, I've got, LOS statements over here and, basically you're trying to do what amounts to a VLOOKUP and some guy comes in and says like, oh, let's throw Kubernetes at it.
Right.
That's not just yet. But I think maybe hopefully what I want to see is a little bit of a rationalization around kind of, we've gone from being kind of a slow adopter to, frankly, I think an over aggressive adopter of like the shiny new thing, and how many companies have jumped on whatever Hadoop. Yeah, that's a great one. I'm like, I dodged the freaking Hadoop. I
remember when they were pushing Hadoop.
My career, like, and maybe this is just technology in general, because I haven't been in, I'm not that old, but I burnt to death of Hadoop, man. Just like,
I remember what they were pushing the shit out of Hadoop.
Yeah, and it was incredible.
How fast it died was amazing too, because it was like, I was, it was 2014, and I was starting to dabble and like trying to figure out what technology, and I kind of pushed that one off, and then like all of a sudden it was like 2 years later, like no one talked about it.
No one talked about it. And so it's kind of a broader thing, but like I would love to see I would love to see people focus more on the fundamentals, like understanding relational data and understanding. What are the advantages of row-oriented versus column-oriented storage?
Just good quality data.
Yeah. That's eternal, right? Yeah. But knowing the details of Hadoop or Snowflake or whatever next year's thing is, like,
they very much so get.
It matters, but it's also kind of ephemeral, right?
They get force-fed, the new shiny things by the consultants and the big three and all those guys, and it's it's good to be cognizant of it, but don't tell your devs we need to implement this today because Gardner said it.
So I hope we kind of calm down. I hope we kind of get some maturity and say, well, all right, we don't have to chase a new shiny, but let's think about what we're really trying to do and what makes sense.
For sure.
So on that, kind of, what's a bleeding edge tech or something that you're actually pretty bullish on?
Ooh, okay.
ChatGPT has been like 80% of this answer. So
so all right.
I know you have opinions.
I'll give you a hot take on
AI.
I don't think ChatGPT is going to take programming jobs anytime soon. So my wife and I actually did a Terminus webinar back over Christmas break on ChatGPT 3 when that first came out, and we do this Abena Code is this kind of yearly coding competition that we kind of do the first like week of every year, and then get tired. It just takes hours and hours. You're like, forget this. But we started doing this competition like John Henry versus the steam engine, where she would run GPT and then I would try to solve the problem. First 3 days, kind of, they're like basic interview level questions. It actually smoked the human. I mean, like the leaderboard was all GPT generated code. By like day 5 or 6 though, it was failing. And what I've noticed is it really just, it is really good at producing an answer that looks superficially plausible, and then you like zoom in and look, and you're like, "This is nonsense."
Or you copy and paste it.
So I don't.
And you're like, oh.
I see it as kind of like I use it almost more like a search engine, because Google's gone to hell chasing the SEO thing. So I'll type in like, "Hey, I'm looking for a plotting library for Rust that can show me, heat maps of spatial data or whatever." And it'll say like, "Oh, it's called blah, blah, blah." And then half the time that doesn't exist, but whatever. It's still better than Google.
Yeah, I think
unfortunately,
that's the scary part of GPT. As far as it is sometimes.
Yeah. As far as what I think is promising, dumb programming language nerd answer is like, I love that we're living through the resurgence of static types and functional programming. I think Rust and even like C#, newer versions to an extent, are taking those ideas and making them mainstream. And I think it's a nice correction in this eternal pendulum of like Java to Python to, hopefully something that looks a lot more like that. That's going to affect the way we do things a little bit. I think Python's not a sustainable substrate to build engineering tools on. I think it's comical. It's kind of become the language of engineering. When you think about what do you need? Well, I need correctness. I need fast, I need good performance for floating point code. And I need, I need something I can leave on a server and run for 20 years. Like, well, Python checks none of those freaking boxes. So I would love to see, like I said, kind of a return to, hey, let's let the computer help us with code correctness. Let's use static types. Let's let's take advantage of some patterns that minimize the complexity of the systems we build. I know the answer you're fishing for, so I'll say it because I agree. This is interesting too. It is interesting to see kind of a move. We lived through the wave of NoSQL and kind of the document store thing, which boiled down to, and I had this saying I probably said over and over, and I've had to say it less recently, which is like, there's no such thing as unstructured data. There's just data you haven't sat down and figured out the structure of yet. Right. Like it's kind of like
Mongo's an easy button while you're trying to figure things out, but eventually you land on a schema.
It's the equivalent of as a kid, your mom says clean your room, and you just like put all your shit in the closet. It's like, it's clean, I guess, but then at some point someone's gonna have to go in there.
She goes,
comes to roost,
put your shirts up, and it all falls out.
Right. So I'll say NoSQL circa 2010s didn't impress me that much. I do think it's interesting to see though some of the newer generation of like column oriented stores, and so I would, in the same spirit as like the weird schizo board full of pens connecting James C. Scott and Lisp, and I see the same thing when I think about like what's happening in game development and the move away from kind of these big object-oriented simulations to things like entity component systems. Same idea. We're seeing across a whole category of multiple categories of application that sometimes it makes sense not to look at things in kind of a row-oriented or object-oriented or, this is a well and it has these 5 attributes and this well has these 5 attributes. But instead flip it around and say, here's these 5 attributes. And these 10,000 wells all have those attributes, because that plays a lot nicer with modern computer architecture in terms of performance for doing certain operations, right? So when we talk about OLTP versus OLAP, like that's fundamentally one of the big distinctions there is like, do you need fast updates and inserts and reads on a kind of a row level? Like show me, here's 10,000 transactions at this Walmart
like time series,
or do you need a fast operation of total up total category A sales plus total category B sales plus total category C sales across all Walmarts in the world? And there's a trade-off there. There's in terms of how you orient the data, and so I see things like DuckDB and other cloud offerings, which I won't be clown myself by pretending to know which ones are oriented which way.
Most of like the big ones, like Snowflake, BigQuery, Redshift, all the modern.
BigQuery is a columnar from what I understand. And so I think that makes sense for certain applications that we have.
Well, cool. Awesome. Well, no, I mean,
where
John's got.
No, I was just going to say, where can people find you? What's your
pretty easy to find. If you look, our Terminus website, I've got a blog at usethee.computer. It doesn't often have to do with oil and gas, but a lot of interesting programming tidbits where we try to, mostly I try to take kind of interesting things from the wider world of programming or computer science and make them semi-accessible, or at least in Python, which is kind of what we have to do, I guess, to reach people these days. So LinkedIn, GitHub, Derrick Turk on GitHub. I've got a bunch of things out there in various states of completion or not, and some of them are even oil and gas related or energy related.
Yeah, no, that's you got quite a bit of stuff on there. It's good. That's why I brought it up so people can go check it out. What's the website? For Terminus?
Terminus, terminusdatascience.com.
Got it.
Yeah.
Keep it simple.
Yeah.
Appreciate it so much.
Yeah.
Thanks for being on. And also, make sure if people like the...
if you guys like what we're doing, please go give us a review, like and follow the DW pages, and we'll see y'all next time. Appreciate it.